Hey, Abhimanyu. Multiply is a beast. Okay, why is this commented out? Oh, okay. Never mind. Yeah, Gabriel, I agree. Delayed template. Copy that thing is true. And this must be just delayed template now. And then on the other side, we must have a identity type void. Hmm. It is not good, this one. But what is wrong? The hell? Shit. product of constant times symbol. Okay, full-blown debugging coming up because, well, I have no idea. I think that maybe the product is a problem here. So I have to delay that as well. But I'd rather just find out what is the exact reason. So it made changes, therefore I compile again to get the line numbers correct, and then we look for if the error is still the same. The problem is in line required from 99.9 for a make power of a symbol and a sum. Well, the sum does not have a power, so that should never have been called. Power.h 99.9, and previously that was the same. Yep, so the error is the same, and it comes from required comes from here. Oh, we're almost at the bottom. That's a tough one, this one. Can't type. So now this is the one that causes the error, for obvious reasons. And well, at the moment that we call operator star on two sums. Why doesn't it tell me which star? Let's copy it all and look at the source code. Maybe we should use a different compiler, one that tells me which one it is. Yep, symbol 0 is obviously A. So this is a -1 times A, which is this. And this is a product of 2 times B. So this is this. And this is this. There we go, including the minus. So the sum here is the sum of -1 times A plus this sum. So this is the sum. So it's about that multiplication. It's the last multiplication. Kinda makes sense, right? Yeah. So let's try to do that in 2 steps then. Auto arg1 is this part. Auto arg2 is this part. And that should not give problems. No, it's just multiply. No, wait a minute. If I do that, then I don't know anymore what it was. Okay, so now the error happens. Oh. Different error. Extended character, something is... Comment it out. Or not. Make power of a sum symbol, I mean, and a sum. Okay, so I think we have still the same error. And this was comes now from drum ruffle. Comes from here. Bar. Yay, so the arg1 and arg2 work. But this multiplication fails. I want to start putting static asserts in stuff, so maybe this will trigger it. No, unlikely, right? This is just a constant times a symbol, and again, and here again, again, so it's never going to be that. Let's not put a static assert inside the multiplication of a constant times a symbol, and then we should be okay. Operator star star.h, a constant and a sum. Isn't it not like this one then? I think it should be this one. I'm talking nonsense. What is being multiplied here? Sorry. Yeah, it is multiplication. Where's my operator star? I don't see it. There it is. That is a multiplication. Between is, yeah, I knew that, but if I scroll down, we get, okay, same. Sum. So definitely should be this operator here. Test if that is the case. Static assert, dependent false, some argument. Let me get here. And indeed, we get here. So that's the one that's being used. And then from there we call one of the multipliers, I suppose. So it's bottom to top is the way it is being calling stuff, or it's not really calling stuff because it's compiled time type instantiations, but nevertheless, this thing calls in between quotes multiply t with e1 is a constant times a symbol, and e2 is a sum of a symbol and another sum. Well, the rest. So we're multiplying -1 times the first symbol with the rest. I need to know what all these types are then. That is E1, right? -1 times only 2, yep. So this is calling a multiply with E1 is that and E2 is that. So clearly that is E1, this E1 times the rest. Maybe not the rest, I don't know. Symbol 10, yeah, it's not the rest. I call it the rest, but it's just E4. Haha. So this is a multiplier between E1 and E4. Now we're there. Okay, this one. That's the one that's being called. So that would be a multiplier between a product and a sum. Which happens to be this one. Product and a non-product. Not sure I can put an static assert like that here. If I can, that would be nice. Seems to work. No, it doesn't. Expected primary expression before. Come on. How do I add a static assert to instantiation of a template class? It's a question I already had before. I doubt that works if I just add a constructor. But who knows? Let's try this. Oh, we get here. And still, that's the same error. Oh, wait a minute. That is something different. I forgot to add the value here. Test it if we stop here now. Nobody sees we get here. Nope. And then we go back to trying without constructor. Also not. Oh, you get here. Yeah, that's the second error. That's the first error, and this one is quite from here, well, same line, but same operator. It is the same thing, it seems. Can I highlight this? Hardly. Well, actually I can. I have highlighted it. I only expected it to be happening before that as well then. So what is different? Strict multiply, product constant -1, comma, symbol, product. Oh, this is sum, this is a product. It's not the same thing, is it? Oh, this is a product. No, wait a minute. This is a product and a product. Product of constant and symbol, comma, another product. What? That was not what we had before, was it? Some E1 is a product. It's so confusing. Huh? Let's try this one. Okay, so now it's the first error. Yeah, this is a different multiplier than I had before. It's still strange. This is the multiplication between the product of -1 and symbol 0 and the product of const of 3/2 with symbol 2. That used to work before. I don't think the static assert is correct here. This comment here is the correct one. This is the one where it should happen. I don't know. Something is wrong with the bloody static assert. See, this the highlighted thing. That's where it is. That is a multiply of a product between a constant and a symbol and a sum. And then I cannot add a static assert here to catch that one. Means that we all call it before. And I don't want that. Product something, because this one came from I don't know, one of the others, some other thing that I added comments at, I think. Here, sum.h. I want to catch this one. But if we add a static assert in it, then we assert somewhere else, which means that there is another product that is instantiated before this one, which is also product something. Sorry, which is also, yeah, it's nonsense. No, it's not product or sum. It's a multiplier. So product something. It's probably E3, E4, or what is it? E1, E2. The wrong reason is, could be this one. 3 is a product, is a product. So this is a product times a non-product. This is a non-product times a product. It's the other way. This is a non-product times a product. None of them is the same as that one. Product. This is product. This is product non-product. And this is a non-product and non-product. So we set a static assert in product sum, then that it should always catch this one. I think there are 2 errors. So I catch this one now. It was first the first error, but for some reason now it's not the first error. And then there is another error here, which I'm only showing 2 errors because of this. But this error now is for multiply between product and product. So that one also fails. Yeah. Okay, well. No, it's not true. Just the product times the product recursively calls this for something simpler. So the static assert catches it, or I don't want it to catch it. One. Would be nice if it showed me the template parameters of this. Oh, yeah, I guess. No, this is the next one, this one. That must be this one. That must be that one. So let's say we don't assert if it is symbol 2. Second argument symbol 2. Because I don't think that is the case here. Here it was sum or something. Or, yeah, just sum. So where's my static assert? Ooh, billions of static asserts. There it is. That is just multiply, of course. Multiply.h. There you are. And now I do not want to assert if this is not the type of E2. So rather we get here only if this is not that type. Yep. Finally, I think, or not. still two of them. Some other error. Ah, okay. I'm a complete idiot again. Static assert doesn't work that way. So this is always false. And the static assert demands that it is true. So it must be an OR. This is always false, but we don't assert if this is symbol true, because then this is true. Finally, now I get only one error. Oh no, actually it doesn't. It still says we have two errors. We still have two static asserts. What the really? I needed to only give me one error, one static assert, because I want to add, you know, static asserts to do the backtrace basically. It's the only way to do it. I want to get at least two of them. So now I have to figure out which one is the one that I want. And then why the other one is static asserting, and then make it not static assert. At least that's the same operator. And then this one calls I think this is the one I want, which is not happening here. That doesn't really matter, I guess. Both go wrong. No, it's not entirely true. Now it goes, both go wrong on the static assert, so that doesn't say anything. You need to static assert in the compile branch, basically, where the error happens. So, and I've got what that error was. So if I edit that file and I remove the static assert, then we see the real error again. which contains this, and the real error is requires this is the error. Invalid use of incomplete type, which usually means that it's trying to instantiate something that I'm totally not interested in, because it belongs to a branch that yeah, a false branch basically. I don't know how else to say it. But in order to find out why that exactly happens, I want to add a static assert and then stop there. You know, okay, this is where we get. This is the point that we pass. And I'm starting to intercept it already here, the moment this multiply is being instantiated. That is then a multiply that has a product. The first argument is a product, and the second is not a product, it's a sum. Yep. And that comes from just have to remember this. It comes from, or this product is minus symbol 0 and the sum of symbol 10 and the sum of the product of minus 2 times blah 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 blah. Let's highlight that part then. Can only highlight one thing. Very annoying. So multiply dot 36 has this highlight for E2. That's the arrow that I want to follow. And now we add back the static assert. So that is this one, lines 36, E2 is that. Which then indeed tries to instantiate a multiplier that starts with a product, and the second one is not a product. And then we static assert. Which then in turn means that everything above here, the first error, is not the error that I want. I think this, the one that I want is at the bottom here we get here, so I do not want this one. So that one comes from a multiply that is a product and a product, which then calls product 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 symbol 0. No, sorry, it's a product of 3 minus 3 halves times symbol 0 with symbol 2. So why is that static asserting then? In instantiation of multiply of a product with a non-product, correct, but the non-product is symbol 2. Required, 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 required. Static assertion fails. And that should not have failed because this should be true. E2 is symbol 2. So this is true. So the whole thing is true. So the static assert should not fail. How is that possible? Oh, it tells you. Evaluates to false. Oh, it compares symbol 0 to symbol 2. So apparently E2 is symbol 0 here. Oh, it's this one. Okay. Whatever. So, symbol 0. Finally. Now I got rid of it. Now I have only one arrow left. So with this E2, we run into... What the way? You gotta be fucking kidding me now. No, it doesn't assert at all anymore. the sum of a symbol 10 of a sum of a product of a constant times a symbol. So this is then again the sum product of that with a power. Yeah. And then the power ends here. Constant power, and then the product ends here. And then the sum ends here. And another sum ends here. And this is the last one's delay template. I need to see them all. How do I add that? They didn't do anything. CXX likes. Did I forget the resource? Oh, it's there. It's now still doing stuff. Stop with it. Yeah, now it's done. Now we have to start at the top again, I'm afraid. So the problem is we have a make power of a sum, which is not allowed. Which is required by the substitution of, well, that's just a substitution. Which is required from delayed template make power, where first argument, second argument is that sum. So yeah, that's not allowed. It is required from instantiation of the conditional type false, which means that we use the second parameter, so not the delay template of the multiply on equals with what it actually should be doing, some blah 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 symbol, but it is using the delayed template of make power, where the second argument is a sum. And it is doing that correctly because this is false, so it takes the second one, which is to make power, but it should never do that. So why do we get there? Required by substitution of, and this again the substitution, let's skip that one. Required from struct delayed conditional type false. Yeah, this is the delayed thing. Okay, so it's practically going to do the same thing. It's again the false. Delayed time template multiply on equals of that thing, blah blah blah, but this is the one that we would use. Delayed template make power t at the symbol with that thing. So the false we should never get here, or the false should have been true. And that comes from, required from conditional value type false. Here what? Delayed template multiply on equals symbol with that thing, comma, delayed conditional type false. Delayed template multiply type multiply on equals. That's some symbol multiply make power to symbol. Okay. So you got to wonder then. Yeah, same thing. Now we have two booleans, but for the rest, the question is now, where do I see my booleans? Here's a boolean, false, and here's one. So either we should not get here, or one of them should have been true, or both. I don't know what, but not both false. Required by substitution. Required from struct multiply. Symbol 0 with that sum. Yeah, well, that's nonsense. So something is horribly wrong in this line. Is this a thing? Line 26. And that says this. Copy. Thank God it is something. Now what is wrong about this thing then? So I feel it coming, but it's escaping me. You know, there's horror movies where you see something on the corner of your eye and you look at it and then it just vanishes through a door. And then you're not sure if you saw something move or not. There's definitely something here. This is the function with the bug. But what exactly is going on here? What is wrong? Yeah, I see more of it. It's starting to slowly get visible. Yeah, even more. We are at 50% now. %90. Yeah. No, maybe it was 80. Okay, I think I have a vague idea now what to do. Let's make this a static const expression. How did I do that before? Less than E2. So the problem is that this conditional type, despite that this is true, does not stop the compiler from trying to evaluate or instantiate these delay templates. I think. Okay, now I'm not sure anymore. But let's continue with the straightforward changes. What is more definitely missing is that it is not using this one. Never, ever, anywhere. That's impossible. That's why the make power is being called. So the idea is that if this is true, then the delayed template, this delayed template is being processed, and therefore we will instantiate multiply on equals t of E1 and E2. And it will not do this one, delayed conditional type. However, hopefully it will also not do this one because, well, it's delayed and we should never get here. But now I'm not sure about that anymore, really. I mean, no. It's like the, yeah. Oh, this code is getting close to the most ugly code that I ever wrote, if you ask me. It's not just unreadable, it's not even possible to reason about it while you're writing it. Yeah, I think, I don't know. Arg. I have no clue. I'm just trying something. Well, it didn't help, apparently. Getting a bit tired already. Nope. Well, this thing isn't firing anyway. something. Tja, der is nog goed. Strange. By default it's false. And then I only make specializations when it should be true. It should be true if the first one is a constant and the second one is not. So a constant is smaller than any other thing, as long as not also a constant. Of course, I should also have a comparison between two constants. Go find that one. Oh, no, I don't. There is never a product between two constants. So and then two symbols are, the first one is less than if the ID is less, and then I have a symbol is less than a power if the ID is less, and a power is less than a symbol if the ID is less, and a power is less than a power if the ID is less. It doesn't talk at all about sums, which means that anything, sum, is always false. So yeah, and then they are equated equal, which is nonsense. Why is that not being listed? What escapes me is that I don't know. Probably means that we should never even get. We should. Oh. Yeah. Okay. No, actually not. This whole short circuit thing, I'm getting really sick of it. I want a const expression. Conditional type. I don't know. Let's add it because it kind of feels that, yes, I need a struct is less product of stuff that should be true, which is now missing. And that is then it's still weird, but it's something not right. Sitting in the dark again is not his power. V2. So a symbol and a power are always less than anything that is not a constant symbol or power. And if neither of the two is a symbol or a power, then I'm 100% not interested in it, I think. Or am I? Maybe even then I'm interested in it. I'm not sure. I just don't know, man. This whole thing also already feels weird. Don't tell me that didn't work. Yeah, now it's two sums. It's chronological. Really, we should never get there, dude. I mean, well, actually, no, wait. I should get it sometimes. Sometimes some of us should get there. But then equal, that's still going to fail. That is still going to fail then. That's still going to try to instantiate make power of those two, which is just no. So yeah, maybe I should do something like it should only be equal if you know both actually are either power or symbol. Yeah, sorry, that doesn't work. So is symbol E1. One is power E1. But yeah, if I do this just to protect make power from being called with non-symbols and non-powers, then it's going to do one of these, which is also stupid. Isn't it? Well, at least I don't even know which one is. Well, just it's randomly false. There should not be any randomness in it. I think I have to. No, I should. I should. It's not that easy, is it? I'm gonna stop. It's worse than I thought. I need new energy before I continue this. Yeah, multiplying. Oh fuck, I realize what the problem is. I finally realized what the problem is. Oh, yeah, I get it. Okay. The reason is that my previous code comes from a product that only accepts certain expressions, and I left out the require. which is not that much of a problem, except that, oh boy, what did I do? Yeah, this code can only deal with symbols and powers, and it should only ever have to deal with that. And now I'm suddenly calling multiply for anything, any multiplication, including sums, for example. That's why everything breaks. Yes, especially sums, right? Especially sums. So this is the code that I copied from product. Product is not a multiplication. It's a product of symbols, exclusively symbols, and a constant. One constant and symbols. But to extend that with other stuff, I have, for example, these defined. So as soon as one of them is a sum or both, I'm suddenly using the wrong code. I'm using this still instead of one of these. This code wasn't copied. So I have to detect if one of the arguments is a sum, or not detect. I just have to make specializations for it. Where we finally got it. So this is missing. I just left that out. Stupid. Yep. Okay, so this is then going to be, let's say, the default. Oh, pretty random, because I think that's easiest. And then I can specialize it for two constants, which would deal with this part. And specialize it for sums. But maybe get other stuff. Well, this is really only intended to be used for one of these things. It's a bit hard to do with specialization. That would be 9 specializations for all the 3 times 3 combinations. I should never have separate symbols. A symbol is just a power with the exponent of 1. Then at least it would only have been 4 possibilities. So I could make it the default and specialize it for sums, but then I'm also have to deal with, well, afterwards with exponentiations. Multiply something with a logarithm and an exponentiation that is not a symbol as a base. And that's going to be slightly problematic. So maybe I should use 2 different types I have a multiply underscore t now, but maybe should just have two of them. One that is used exclusively for these, and then one that is more, yeah. Or can I not just copy this and then use it? Copy this. Okay, that's an idea. It's like the definition of a product. So is product, whatever. So definition of what I call a product. So yeah, so then I get something like if is product, then we can do this. And then I don't have to deal anymore with that E2 is a sum. Because if E2 is a sum, then this is false, or this is false. At least that's the idea. So I still have to make it work that it is actually not trying to instantiate that type then. The more I'm working on this, the more I think that C++ is not very good language, really. There's so much that would be possible if it was designed better. For example, they just added, like I said before, as an afterthought, apparently, concepts. So concepts means I could this thing came from operator star with a requires. I could add a requires here. So making either use this isn't a concept, but well, the same thing. We just add here requires con type, and then this expression. But that doesn't work well with specialization, which is just really bad design then, if you ask me. Because if I want to specialize this struct for certain expressions, like sums, right? So then I repeat it here, and like I do here, I'm a specialization for constants, yes? And we have specializations for products. So I want to make a specialization for where one of the expressions, one of these two expressions here, is a sum. But if you do that, then it demands that specialization uses the same requires. So if I restrict this thing with this requires, then I can only make specializations for the same requirements, which is not what I want. And as a result, I cannot use requires. Therefore, the only way to get rid of anything that causes this to be false is to make specializations for every possible combination of types that causes this to be false, which is 9 of them. Yes. Not even counting the constants, but okay. This is like, if this is a constant, then the other one must not be a constant. Why is that? Because I have a specialization for 2 constants. So only one of them can be a constant, and then we'll use this. If both are a constant, then this specialization is going to be used. Okay, so that's even more then. So one can be a constant and the other can be not a constant, but can be, so E1 is a constant and the other one is a symbol, a power, or a product. That's 3. Or E1 can be a symbol and then E2 can be a constant or a symbol or a power or a product. That's 4. So then we are at 7. And then again plus 4, that's 11, and again plus 4, that's 15. So you need 15 different specializations just because I can't use requirements together with specializations. And I really think this is just bad design of C++. They just forgot that this is blah. I would do it differently. And even if I'm willing to make 15 different specializations, each of them should be doing the same thing. Namely this block. So probably the best thing then is to have every specialization derived from a base class that is doing this. I can make a base class called struct multiply products or something like that. And then make 15 specializations that all derive from that. But yeah, then if that's necessary, then don't tell me that this design is very good. And then I mean the language design. But maybe that's the way I have to go, the route that we have to take. Anyway, now I have 15 minutes left to buy some dinner, or I could no, I'm gonna buy a microwave thing dish.